So we can cancel G, or grams, because I've got one on the top, one on the bottom. If I had X on the top, X on the bottom, I'd cancel those out. Okay? I've got CO2, the species, on the top here, CO2 on the bottom here. So I can cancel those because it's just like X's and Y's. If I had a Y on the top here, I could cancel a Y on the bottom. All right? So now we're ready to do the math. We're going to take this number. Well, technically, we're multiplying this number times 1, but doesn't that give you the same thing? So it's like we are multiplying, but we're kind of leaving out the step because that's a really simple step. You can do that in your head, right? And then once you multiply what's across the top, you divide by what's on the bottom. Well, 1 times this number gives you the same number. So while you are multiplying and you are multiplying down here on the bottom, we're really, in practice, just taking this number divided by that number. Does that make sense to everybody? Okay, so if you do that math, you get 0. Who's got a calculator? If you got a calculator, you need to practice. The more you practice, the better you're going to be on the test. Perfect practice makes perfect results. Okay? Doesn't mean you're absolutely always going to get perfect results, but you're more likely to get perfect results if you practice perfectly in class. Okay? So what's on the top gets multiplied, what's on the bottom gets multiplied, then we divide the top by the bottom. Got that? That's one way to think about it. So, see if you get the same number I do. Know what you got?
Yeah. Do you have to write all that out?
Well, yes. But you don't have to, yeah. Your calculator might not go that far. That's okay. Your calculator might stop at 9. This would be a 9, 7, 8 or something. Just write the number you have. Just write the whole answer you have, okay? All right. Now we have to say what that number is, and that's moles of CO2, okay? Now, not just to write moles, not to write CO2, it's moles of CO2. But now we're ready to figure out what the significant digits are and to round properly. Okay? All right? I got 2, 7, 8, 3, 4, 8, 9, 9, 2, 8, 3, 1. That's okay. If it stops at 8, it stops at 8. You write down what you got. All right, now, to figure out what the significant digits are that you need to keep, we need to identify in this part of the problem what our measured and calculated numbers are. Now, this number 1 is a counting number. It's really more a placekeeper than anything else. But it's a counting number. Ignore it. When it comes to the significant digits, now, we can't always ignore counting numbers. But for figuring out significant digits in multiplication and division, we ignore the counting numbers. We only care about measured numbers and calculated numbers. Okay? Now, you can't always tell, but one good hint that you've got a measured or calculated number is it's in the form of a decimal. Okay? So this is one of our measured numbers, and the hint is, a good clue is, I got a decimal place. Okay? Numbers in the decimal places. Okay? So that's a good clue. That's a measured number or a calculated number. Same here. Okay? And this is measured and this is calculated. You can interpret it from the problem, or you can kind of do the best guess you can, but measured or calculated numbers in chemistry, most of the time, not always, most of the time, we'll have decimals or we'll have decimal places, okay? So, then from those measured and calculated numbers, we've got to figure out which one has the least total digits. So, this number and this number, which one has the least total digits? The first number, 12.25, has 4 digits. This one has 6. So this is the one that's going to form the basis for figuring out the significant digits in the answer. This has 4 digits. That's how many digits I want my final answer to have. Okay? Because it has the least number of total digits. Got it? So it's a different rule than addition and subtraction. Least total digits of the measured or calculated numbers. And then we're going to go over here and figure out how to figure out what our 4 digits are here. If we got 4 digits for the least digits here, we want 4 digits here. Okay? The 0 is do we count the 0?
Yeah.
No, it's a leading zero. Remember? Okay, just testing. All right. That's good. Look, I want you to speak out. That's a good thing. All right? Because I can't identify your misunderstandings if you don't let me know what they are. Okay? So please, don't feel bad if you give me a wrong answer if you're not just, just wildly guessing. All right?
Does these rules apply to Division 2?
Yes, and this is division here, isn't it? We are dividing this number by that number. It is multiplication and division, yes. Okay? So leading zeros are not significant. Remember, the only significant zeros are those that are between two significant digits or zeros that are both after a non-zero digit and a decimal place. All right? That's the formal rules. The informal rule is leading zeros are not significant. Got it? Remember that? All right. I don't see much many heads going up and down. No bobbleheads in here. Okay? All right. How do we figure out how many significant digits here then? 1, 2, 3, 4. The 0, we don't count that because that's an insignificant digit. It's a leading 0. So everything after this 3 here gets underlined to show that it's insignificant. Okay? But then we have to finish. We have to round off. And the operator we said for showing we're rounding off is an arrow. Then we write the answer. 0.2783. Have to have the units and species to tell what the number is. Okay, a number by itself is just some theoretical thing, right? Got to tell me what it is. It's moles of CO2. And then I want you to please put a box around it just to tell me, just to communicate to me that's your final answer. Okay? All right, that makes sense? All right, would you like to do a problem, practice problem?
Yeah.
Let me give you a problem to do. Okay, all right. Remember, always write your equality statements, okay? What now? That right there? Yeah, that's a 3. You can use the rest? Yeah, sure, you can, and you may. All right, everybody got it? Ready for the practice problem now?
Why do you put that little square behind it?
Oh, if you're writing a mathematical statement, especially in college math, when you're writing what's called a proof, that's like the final period on the whole proof. Okay, it tells you we're done. Fine. If you're a musician, fine. All right?
So do we need to have that on our
No, not really. I'm just doing it so you can kind of see it, and so when you get to college math, I saw that Mr. Tucker did that, that kind of thing. So it's not entirely foreign to you. All right? All right, so here's your practice problem. At Myrtle Beach on a freezing day, that's supposed to be an N right there. Yes, that's 22.4. All right, now you can solve this problem with a neighbor if you need a little bit of help. Okay? or find somebody to help you if you're struggling a little bit. I'd rather you do that than call on me, because there's only one of me and there's like 27 of you guys. So you'll get help faster if you'll get a neighbor who grasps this stuff to help you, then wait for me to come around and help you, okay? We're trying to be ready for the test tomorrow, so you need the help as fast as you can get it, right? So at Myrtle Beach on a freezing day, and when I say on a freezing day, I mean it's the freezing temperature of water, okay? That's what I mean by a freezing day. I'm kind of simplifying things here a little bit because the actual temperature is supposed to be 0 degrees C. So I'm just being a little more general here because we haven't gotten that far in chemistry yet. Okay?